is a client server protocol used to provide the network configuration parameters to the clients automatically by a server. So instead, whenever a new device comes to the network, instead of an IT administrator, sorry, network administrator, statically assigning an IP and providing configuration to the device, this protocol automatically provides the network configuration informations such as IP address, subnet mask, and DNS IP and gateway informations to the client. It makes use of UDP, that is user datagram protocol, and port number 67 is used by the DHCP server and port number 68 is used by the DHCP client. This DHCP makes use of a process known as DORA process for its operation. Let's see what is DORA process. So DORA process is nothing. It's D for discover, O for offer, and R for request, and A for acknowledgement. Whenever a client newly comes inside a network, it's broadcast a discover message to discover the DHCP server. So once the server received the discover broadcast message from the client, it sends an offer message with its next available IP address to the client. So once this client receives the offer message from the server with the next available IP address, this client again sends a request message to the server to bind or to map this particular IP address to this device. So once this server got the request message from the client to map this particular IP for this device, then this server will map the IP for this device in server and sends an acknowledgement to the client. So once it sends an acknowledgement to the client, and then that particular IP will be assigned for this client. This is what DORA process. Let us see practically how does it works. So in this scenario, we'll see how does DHCP works. So here I have configured this DHCP server with the IP address of 10.0.0.200 with a DNS of 8.8.8.8, and I have not assigned any IP address for these devices. It's a plain devices, and it's a 10.0.0./24 network. And we'll see how if this is a new device, it gets into the network. Let's see how it will get the IP address in practical. So let's see how does it works. First, PC0 will send a DHCP broadcast message with destination IP addresses 255.255.255.255 and MAC addresses all F. That's it will broadcast a message with an port number, destination port number is 67. So this broadcast will be received by all the devices in the network. So as the port number 67 belongs to the server, not to the client, this clients will be discarding the packet. And once the server receives a broadcast message from this client, then this server will assign an IP address for this client. So before that, it will send an ARP message to make sure the IP address that's going to be assigned for this PC is not already assigned in the network. For example, now 10.0.0.1 is the IP address that's going to be offered to PC0. So before that, this DHCP server is sending an ARP message with a destination IP address as 10.0.0.1 to make sure this particular IP is not yet provided in the network. So an ARP message is broadcasted in the network. As it's not yet provided already, it won't get any reply. So this DHCP server concludes that this IP is not yet provided. Then this DHCP server will send an offer message to the PC0 as destination is this thing. The offer message will also be an broadcast message. So this is the offer message that was sent from the DHCP server. Source address is 10.0.0.200, nothing but DHCP server. So now the DHCP server has allocated or offered an IP address that's 10.0.0.1 for PC0. Now this PC0 will again send a request message to the server to map this particular IP address for this device. It's a request message again broadcasted to the server. So once the server receives the request broadcast from this PC, it will map this particular IP address for this PC, that's 10.0.0.1 for the PC. Then it will send an acknowledgement to the PC0. So now this PC0 got the IP address of 10.0.0.1 and the subnet mask 255.255.255.0 and default gateway 10.0.0.100 DNS server 8888. So this is how the clients in the DHCP network got the network configuration parameters such as IP address, subnet mask, default gateway and DNS IP from the server. So once it gets acknowledgement from the DHCP server, again this client sends an ARP message to make sure this IP is not already present in the network. So see, the source IP is 10.0.0.1 and the destination IP is 10.0.0.1. It's just to check whether this IP is already available in the network or not. As this IP is not already available in the network, there won't be any reply message for the client. So now this PC will make sure this is the IP address of this PC. So by this, now the PC got the IP of 10.0.0.1 and let's see how PC1 gets an IP address. Let's keep the IP configuration as DHCP mode in the PC1. So this will broadcast an DHCP discover message, and as the port number 67, this other clients in this network will discover the message, and he will send an ARP message to make sure the IP address that's going to be provided for PC1 is not already available in the network. And as there is no return reply for that ARP message, it will send an offer message for the PC1. The IP reserved for PC1, the DHCP server is 10.0.0.2. So once it gets the offer message from the server, again it sends an request message to map this particular IP for this device, that's 10.0.0.2 for this device. So once it gets the request, again it sends an acknowledgement, states this IP has been now binded for this device. If you see, now this IP 10.0.0.2, the subnet mask and default gateway information and DNS information is provided by the DHCP server. So once again this PC0 will send an ARP message to the network to make sure this IP is not already available in the existing network. So as this IP is not already available, that's 10.0.0.2 is already not available, so there won't be any reply message for this ARP request. So this is how DHCP works.